What if Martians came to our planet? What if a Mars rover brought back some unknown organism that began to reproduce and wipe out all life on Earth? Well, we've seen this scenario hundreds of times in movies and read about it in books. But in reality, the situation is the opposite. We are the threat. Humans are the ones that could infect another planet. We are the ones that could become the destroyers of Mars. And to prevent that from happening, countries created an international agreement that forbids us from taking certain actions on our red neighbor in space. It sounds like science fiction, but it's real. This agreement is called the Outer Space Treaty. It was signed in 1967 by the Soviet Union, the United States, and the United Kingdom. The treaty states that no country that signs it can claim sovereignty over any celestial body. It also contains many other important rules, but one of them directly addresses how we should search for extraterrestrial life. Now, there's a possibility that certain regions on Mars could potentially host life. However, according to the Outer Space Treaty, exploring these so-called special regions is prohibited. That sounds strange, doesn't it? Searching for life on Mars is one of the main goals of the entire space industry. So, how can these areas be off-limits? Well, the reason is contamination. When we explore these regions, we might accidentally bring life there. A tiny but extremely resilient microbe or bacterium could hitch a ride on a spacecraft, land on Mars, and begin to reproduce. But scientists are not only afraid that Earth's bacteria will destroy Martian life, there's a possibility that these two types of bacteria will mix, and we will not be able to separate one from the other. But what if it occurs that these bacteria were originally from Earth? Imagine NASA spending billions of dollars collecting samples of Martian soil, where life has been detected. The spacecraft brings these samples back to Earth. Scientists analyze them and suddenly realize that these Martian bacteria are actually ours. They had arrived on Mars 10 years earlier, when a robotic rover was simply taking pictures of the Martian landscape. Here on Earth, we already know bacteria that can survive extreme pressure, incredibly low and high temperatures, and even the complete absence of oxygen. For such organisms, adapting to Mars conditions might not be that difficult. But what if they change in that environment? What if they mutate and take on new forms? Scientists might believe they've discovered true alien life, when in reality, it's just Earth microbes that evolved on Mars. There's also a chance that Martian microorganisms could mix with Earth bacteria, making it impossible to separate them. In short, exploring places where life might exist could create massive scientific confusion. And what if contaminating Mars with Earth's life causes it to spread rapidly? What forms would that life take under conditions completely different from Earth's? Mars and the Moon can be explored, but it must be done with extreme caution to avoid biological pollution. And don't worry, the Outer Space Treaty also requires us to be careful not to bring potentially harmful Martian life back to Earth. So, what exactly are these special regions on Mars? Well, they're places where conditions might allow microorganisms to survive, which are warm and wet spots. But here's the ironic part. We currently don't know locations on Mars that meet these criteria. But if there are such places, we can't reach them. So in practice, this law about special regions hasn't really been tested yet. However, scientists also talk about uncertain regions. These are areas that could potentially be classified as special regions after further study. One example is recurring slope lineae, or RSL. These are dark, narrow streaks that appear seasonally on Martian slopes. At first, scientists believed these streaks were signs of liquid water. Later studies showed that RSL are formed by dry granular flows. So, does that mean there's no chance of finding life on Mars anytime soon? Perhaps. But what about all those headlines claiming that water was found on Mars? Couldn't that mean life exists there? Yes, scientists have discovered water, and it's not just small amounts, but entire oceans. The problem is that this water is buried 7 to 12 miles beneath the Martian surface. For comparison, the deepest hole ever drilled on Earth, the Kola Super Deep Borehole, is about 7.5 miles deep. We couldn't drill deeper on our own planet. Now imagine how much time, money, energy, and technology would be required to make a giant pit on Mars. For now, such a mission sounds more like sci-fi than reality. But let's say we do find a microbe on Mars and bring it back to Earth. What kind of danger could such a tiny organism pose? Well, science fiction thrillers give us dramatic answers, but there's also a real-world example. Take the fungus known as chytriid. This microscopic organism reduced populations of frogs, salamanders, and other amphibians across the globe. And this biological disaster affected humans as well. Chytriid is not an alien organism, but its story perfectly illustrates what can happen after even a small biological contamination. When chytriid infects a frog, it causes a severe disease. The fungus attacks the animal's skin, disrupting its ability to regulate water and electrolytes. Electrolytes are salts and minerals essential for biological functions. When this system breaks, it leads to heart failure. The frog doesn't survive, and the fungus continues to multiply and infect other creatures. The outbreak was first detected in northwestern Costa Rica in the early 1980s. From there, it spread south and east, reaching Panama in the 2000s. More recent research suggests that chytriid originated in East Asia and spread worldwide through the pet trade. How it evolved the ability to devastate amphibians is a story for another video. For now, let's focus on the consequences that still affect us even today. Over several decades, the chytriid epidemic caused massive declines in amphibian populations worldwide. Around 90 species disappeared entirely. The impact was especially severe in Costa Rica and Panama. As amphibian numbers dropped, so did the populations of predators that fed on frogs and salamanders. But that wasn't the main problem. Remember what frogs like to eat. They catch mosquitoes and various bugs. So after the fungus pandemic, the insect population increased dramatically. Now think about what is dangerous about mosquitoes. Yes, they bite and leave an itchy mark on your skin. But some species carry dangerous infections, such as malaria. As frog populations decreased, malaria cases among humans increased. Studies show that infection rates began rising about a year after amphibian decline started. Over the next 3 years, the number of malaria cases rose, but then stabilized. About 8 years after the chytriid outbreak began, malaria rates started to decline and eventually returned to previous levels. Does that mean frog populations recovered? Unfortunately, no. Amphibians are still struggling. It's possible that humans simply took stronger preventative measures against malaria, or perhaps other animals began feeding on mosquitoes. Either way, the ecosystem never fully returned to its original balance. This is the core problem with biological contamination. Damaging one species disrupts an entire system. Like a chain reaction, problems spread from one link to the next. If a simple fungus managed to affect life on Earth where humans can fight epidemics, imagine what a microbe could do on Mars. Even if life exists there, a single Earth organism could wipe it out completely. The reverse is also true. A Martian microbe could cause serious problems on Earth. Imagine a spacecraft returning from Mars and landing in the ocean. A Martian microbe jumps into the water and attaches itself to a shark. The shark begins to change into something terrifying and starts attacking other sea creatures. Fish become more aggressive and begin attacking anything that moves in the water. Mars's bacteria is multiplying. The fish becomes unsuitable for food. Fishing industry suffers losses, and many people begin to experience hunger without fish. Marine mammals disappear, and things get worse and worse. Okay, let's not be so dramatic, but you get the idea. The red, parched earth under your feet is shaking. Large cracks are opening in the ground, threatening to swallow you. But unlike on Earth, these quakes aren't coming from within the planet. A threat coming from space is triggering them. Scientists have made a shocking discovery about Mars quakes. By using AI and NASA's InSight data, they found out that some of those tremors are caused by meteorite impacts. It means that Mars gets hit 2.5 times more often than we thought. and new craters are forming all the time. But the scariest part is that these impacts don't just shake the ground. They send powerful shock waves deep into the planet, revealing a hidden seismic highway and an unstable interior, unlike anything we imagined. This changes everything we thought we knew about Mars. So now, the big question is, what else is lurking beneath the surface? But let's follow scientists' train of thought first. They took Marsquake data from NASA's InSight lander and compared it with fresh impact craters spotted by the Mars Reconnaissance Orbiter. That's when they discovered that some impacts create a seismic highway through the mantle instead of being absorbed by the crust. Even though NASA shut down InSight in 2022, its data is still precious. The lander, which placed a seismometer on Mars, recorded over 1,300 Mars quakes, some caused by underground rock cracking under heat and pressure, others, apparently, by meteoroids slamming into the surface of the red planet. By studying how seismic waves move through the crust, mantle, and core, scientists keep piecing together Mars's deep structure. In the past, researchers already linked impact craters with seismic data. But these new studies are the first time when a fresh impact has been connected to quakes detected in Cerberus fossae. That's a highly active region 1,000 miles away from InSight. Scientists have discovered this 71-foot-wide crater much farther from NASA's InSight lander than expected, if we consider the strength of the seismic waves it produced. Mars's crust was thought to absorb most of the energy from impacts, which would limit how far seismic waves could travel. But the analysis of this crater revealed that, instead of getting dampened, the waves took a more direct and deeper path through the planet's mantle. This unexpected finding suggests that Mars has a seismic highway, which allows quakes to spread much farther than previously believed. Now, the InSight team will need to reassess their models of Mars' internal composition and structure. And then, we might better understand how impact-generated seismic signals can reach such depths. Manually sorting through the vast amount of data would have taken years. But luckily, these days, there are new tools, and scientists can go from tens of thousands of images to just a few in a matter of days. So, researchers focused on finding craters within approximately 1,800 miles of InSight's location. Their aim was to identify those that formed while the lander's seismometer was active. By comparing before and after images from the context camera over time, they identified 123 fresh craters to cross-reference with InSight seismic data. Out of those, 49 craters were potential matches for quakes detected by InSight seismometer. And after conducting some more analysis, the team decided that the 71-foot Cerberus fossae impact crater was the main finding. This discovery is likely to help scientists differentiate between signals from internal quakes and those caused by meteoroid impacts. Initially, they believed that Cerberus fossae produced a lot of high-frequency seismic signals linked to quakes originating inside Mars. But the new data suggests that some of this activity may have been caused by impacts, not internal processes. Another mystery scientists haven't been able to crack for 50 years is why Mars is split into two very different halves. But thanks to recordings of Marsquakes, they may have finally found the answer. Since the 1970s, researchers have known that Mars has two distinct regions. The northern lowlands cover about 2/3 of the planet's northern hemisphere, and the southern highlands make up the rest. The southern highlands sit about 3 miles higher than the northern lowlands, and the crust, the planet's outer layer, like a shell, is thicker in the south. This strange divide is known as the Martian dichotomy. There are two potential explanations for this imbalance. One theory suggests that an unknown internal process within Mars created the difference. The other claims that a massive collision, probably with a moon-sized space rock or several smaller impacts, once reshaped the planet's surface. But Mars' surface is extremely old. That's why pinpointing exactly what happened has been difficult. But now, a new study, published on December 27, 2024, has used Marsquake data from NASA's InSight lander to figure out whether the cause of this difference lies deep inside the planet. InSight was positioned near the boundary between the northern lowlands and southern highlands. Its mission included recording seismic data from Marsquakes, which travel through the planet's mantle, the rock layer beneath the crust. So scientists compared how these waves moved under both lowlands and highlands. They looked for differences in the planet's deep interior. It turns out that the seismic waves lost energy much faster when traveling through the southern highlands. It means that the mantle beneath this region is significantly hotter than in the north. It's compelling evidence that internal planetary forces, rather than an external impact, cause Mars' unusual split. The research team believes that the temperature difference between Mars' two halves can be traced back to ancient tectonic activity. It once shaped the planet but later stopped. At some point in the past, Mars had moving tectonic plates like Earth's. As these plates shifted, they, along with the molten rock beneath them, could have created the Martian dichotomy. But eventually, the movement stopped, leaving behind what scientists call a stagnant lid. That's a thick, immobile layer over the planet's molten interior. If this turns out to be true, it might mean that the mantle beneath the southern highlands is still pushing upward, while the mantle under the northern lowlands is sinking deeper toward the planet's core. This ongoing process could explain why Mars' crust is thicker in the south. At the same time, we can't completely rule out the idea that an external impact created the dichotomy. Some recent studies suggest that a giant collision could still be a possible explanation. To solve this mystery for good, scientists will need more Marsquake data and detailed models of how Mars originally formed. By the way, if you ever decide to visit Mars, you might come across the hero of our video today, the InSight lander itself. It was supposed to launch in March 2016, but a problem with one of its instruments caused a delay. It was a vacuum leak in the seismometer. NASA rescheduled the launch for May 2018, and the issue was fixed in the meantime. But this delay increased the total cost from $675 million to $830 million. Still, InSight successfully landed on Mars on November 26, 2018. But over time, dust built up on its solar panels, making it harder to recharge. The InSight lander runs on solar panels and batteries, but it needs occasional wind gusts, called cleaning events, to clear dust from the panels. Unfortunately, the place where InSight landed didn't get enough of these winds to keep the lander fully powered. By February 2021, during the Martian winter, thick dust had covered the panels, and they were only producing 27% of their full capacity. To save power, NASA started putting InSight into hibernation mode, shutting down instruments gradually to keep its electronics warm. They hoped better weather would allow the lander to recharge and wake up by July 2021. In May 2021, the team found a clever way to restore some power by using the lander's arm to move sand onto the panels, helping the wind clean off some of the dust. But eventually, InSight was only generating 1/10 of the power from the sunlight than it did right upon arrival. In July 2022, NASA put it in low power mode to keep detecting Mars quakes. The lander kept operating until December 2022. On December 20th, NASA announced that InSight had lost contact with Earth on December 15th, and the mission officially ended on December 21st, 2022. Well, it's official, there is life on Mars. No, it's not a clickbait. Let me break it down for you. Most people imagine extraterrestrial life as little green and, preferably, intelligent people. But we need to distinguish between life and intelligence. When someone tells you there's life on another planet, you probably immediately think about some smart being you can converse with. But life is something different. It's often associated with organic. And NASA's Curiosity rover has found the biggest organic molecules ever seen on the red planet. They were hiding in super old Martian rocks, and I mean about 3.7 billion years old. These kinds of molecules can be leftovers from stuff like fatty acids, which help build cell membranes. It may not be the life we're used to thinking of, but at the very least, the ingredients for what we call life have been there. So, NASA's Curiosity rover has been cruising around a huge crater on Mars called Gale Crater. Scientists think this crater used to be a lake several billion years ago. The rover's main job is to find out if Mars ever had the right conditions for life. And one day, Curiosity drilled into a chunk of ancient mudstone in a spot called Cumberland. It collected some rock powder, and scientists ran a special test on it using a tricked-out oven built into the rover. That oven gets really hot, about 1500 degrees Fahrenheit. Luckily, the experiment's conditions allowed the researchers to cook off molecular oxygen, which limited the risk of combustion. And they found something surprising: chains of carbon atoms, up to 12 atoms long. You can find similar chains on Earth in everything from crude oil to, here we come again, living things. You may say that so far, the discovery doesn't sound too earth-shattering. But wait! Yep, these molecules can form naturally through non-living processes, like reactions with water, heat, and minerals. Hydrogen, carbon monoxide, heat, minerals – well, that's enough to cook up these molecules, even without biology. At the same time, such molecules are also common byproducts of life. Here on Earth, we produce similar compounds all the time, especially as carboxylic acids, which are everywhere in living organisms. So, even though these chains might have formed naturally, they could also be leftovers from something once alive. Maybe microbial life, maybe something way more complex. We just don't know yet. But the most unusual and intriguing thing about the molecules is that these carbon chains are pretty fragile. On Earth, sunlight, air, and water would break them down over time. Yet, they're still on Mars after billions of years. So, even if these molecules don't belong to Martian dinosaurs, we now know that the red planet is good at preserving organic stuff. And this is huge for the search for ancient life. There's a good chance that chemical traces of that life might still be hiding in the rocks, and apparently, Curiosity is capable of detecting them. Now, by the way, this is not the first time Curiosity has found organics. It's also picked up chlorinated organics, sulfur-containing stuff, and nitrates, basically ingredients that, if life ever brewed on Mars, would have been part of the recipe. Now, how about we talk about another hero sent to Mars to make incredible discoveries? Meet Perseverance. It's a car-sized robot NASA once sent far away from home to the inhospitable and dry red planet. In particular, to an ancient crater called Jezero. The Jet Propulsion Lab created Perseverance and prepared it for its first space journey, which started on July 30, 2020. For 7 dark, lonely months, the robot was traveling through the cosmos. Luckily, it managed to land on Mars safely on February 18, 2021. NASA even gave its landing spot a cool name, Octavia E. Butler Landing, after the famous science fiction writer. Since then, Perseverance has been busy exploring the red planet. As of April 8, 2025, it's been active for 1,469 Martian days, which are, by the way, called sols. That's about 1,510 Earth days, or a little over 4 years. The rover looks a lot like its older sibling, Curiosity, but it boasts some upgrades. It's literally loaded with tech: 7 scientific instruments, 19 cameras, and even 2 microphones to record sounds from Mars, like the wind or the crunch of the rover's wheels over rocks. Perseverance also brought along a tiny flying buddy. It's a mini helicopter named Ingenuity. Ingenuity made history by performing the first powered flight on another planet on April 19, 2021. It was only meant to fly a few times, but it kept going and made 72 flights in total. Unfortunately, on January 18, 2024, it got damaged during a rough landing, so NASA officially retired it. As for Perseverance, it has big goals. It's searching for signs that Mars once had life, especially in areas that used to have water. In its search, the rover is trying to figure out if the red planet even had the environments that could have supported life. It's also searching for past microbial life, collecting rock and soil samples to bring back to Earth one day, and testing out cool tech, like making oxygen from the Martian air to help prepare for future human missions. After landing in Jezero Crater in 2021, Perseverance got to work right away, starting with its first campaign called Crater Floor. It drove south from its landing site and explored a spot called cite. Then it returned to crater floor, fractured rough, and collected its first rock sample there. This was just the beginning of its exploration of Mars history. In its second campaign, Fan Front, the rover made its way toward an ancient delta where a river used to flow into the crater. Perseverance climbed up a valley to check out higher ground, looking for more clues about the past of the red planet. The third and fourth campaigns, Upper Fan and Margin Unit, had the rover studying rocks that could tell us more about the planet's climate and whether it could have supported life. In December 2024, they started planning Perseverance's fifth campaign, Northern Rim. It's supposed to study the crater's rim, where rocks from deep below the surface were blasted to the top during an impact billions of years ago. Perseverance has made some awesome discoveries so far. It found volcanic rocks on the crater floor that showed they interacted with water. This was a surprise, because scientists thought the rocks would mostly be sedimentary, not volcanic. At a place called Wildcat Ridge, the rover even found signs of an ancient lake that could have supported life. The rocks Perseverance has found are great at preserving potential signs of past life, so this is a really big find. The rover has also discovered some of the sediments in the delta were deposited by calm waters. But later, massive floods brought large boulders into the crater. It means that Mars's climate must have been changing over time. Now, on top of that, Perseverance has done a few cool experiments. The MOXIE experiment managed to produce about 4 ounces of oxygen from the Martian atmosphere. It could be really helpful for future human missions. The rover also used its microphones to study sounds on Mars. It turned out that sound traveled more slowly there than on Earth. Plus, it was quieter on the red planet. The rover's Pixel tool analyzed rocks and found a bunch of minerals like ovoline, clays, and carbonates. This discovery showed that water had always played a big part in shaping Mars. The RIMFAX radar also helped the team see that the crater floor was made up of solid rock and volcanic material, and that the delta had formed in a calm lake-like environment. All in all, Perseverance has been giving us a much clearer picture of Mars's past. It's discovering evidence of volcanic activity, water, and environments that could have been suitable for life. It's also helping scientists gather crucial data for future missions. By studying the planet's geology, atmosphere, and potential for life, Perseverance is setting the stage for future exploration, and one day, maybe even for humans to walk on Mars.
And we have liftoff of Mars Global Surveyor as America begins its journey back to the red planet.
There's a weird structure on Mars, a square. A near-perfect square standing alone in the endless red desert. And it looks too perfect, too precise to be anything but artificial. Nature's chaotic, and it rarely makes things look so deliberate. So the internet took one look at it and lost its mind, as the internet tends to do. The image spread like a virus on social media, igniting every conspiracy theory you can think of. Some were convinced it was proof that intelligent life had once tread upon the Martian sands. Well, let's dive in and sort it out. The image is real, and it's really old. The thing, not the picture. NASA's Mars Orbiter camera snapped it in 2001, capturing a tiny slice of Martian terrain, and there sat the square. Now, is that evidence for intelligent life? Well, Mars is an empty world now, a rust-colored desert. But once, long ago, it may have been something else entirely. A planet filled with roaring rivers, vast oceans, and thick clouds rolling across the sky. Now, in a world like that, life, if it ever had a chance, could have taken root. And there's a possibility it did. Scientists think that life could have existed on Mars in a short period from around 4.1 to 3 billion years ago. It could have started during the early era of Martian history, called the Noachian period, and lasted all the way to the late Hesperian period. Meanwhile, here on Earth, the first oceans were just forming. Life on our planet was just beginning, in the form of tiny bacteria in deep-sea hydrothermal vents. While Mars was already fully wet, on Earth there were no plants or animals, just microscopic life trying to survive. So Mars took the lead in the life game. It had a much thicker atmosphere, which could have trapped enough heat to keep water liquid. Valley networks, huge traces across the red landscape, show us the incredible story of rainfall, rivers, and lakes. Huge asteroids were still hitting Mars at the time, and they could have brought organic molecules with them. But if that's true, what happened and where did life go? A recent NASA study suggests that the answer is more complicated than we thought. Astronomers believe that something drastic happened to Mars, like boom, and its cozy climate was gone, its atmosphere thinned. Without a strong magnetic field like Earth's to protect it, solar radiation stripped away the air, leaving Mars cold and dry. The ocean simply evaporated. Some of the water escaped into space while the rest froze underground or became locked in polar ice caps. Today, all that remains is a ghostly memory, dry channels and salty mineral deposits. But it looks like the transition wasn't sudden at all. It was slow and gradual. The planet was changing from wet and warm to cold and dry over millions of years. In fact, Mars kept its ocean even after the temperatures dropped to freezing. Some parts of Mars, especially the northern lowlands, might have remained wet for many, many centuries. Shouldn't the water freeze when it gets below 32 degrees Fahrenheit? Well, yeah. But there are many reasons why this miracle happened, like Mars's thick atmosphere and warm water traveling through currents. And during that time we mentioned before, from Noachian to the late Hesperian, life could have found a way. Microbes on Earth thrive in some of the harshest places, beneath Antarctic ice, in deep sea vents, in toxic volcanic lakes. Hey, life doesn't care. So these times in Martian history would be amazing for it. But don't be mistaken, Mars was never a paradise. Even during its cozy times, it wasn't as lush and green as we might imagine. In its early days, Mars was something more extreme, something closer to the young Earth. During the Noachian period, it was warm yet wet. Then the climate shifted into the Hesperian period. Oceans were stretching across the northern lowlands. Temperatures dropped, and snow piled high, forming massive glaciers in the south, transforming the planet into an icy world. Finding microscopic life at that time is possible, but an intelligent civilization? That's less likely. The square that went viral isn't evidence for intelligent life yet, and here's why. First things first, people freak out because nature doesn't make straight lines. But that's not really true. Actually, nature does it all the time. For example, here on Earth, we have the Giant's Causeway in Northern Ireland, a beautiful field of hexagonal basalt columns. These are completely natural. They're formed by volcanic activity. There's also the Devil's Tower in Wyoming. Hey, remember it from the Close Encounters movie in the 80s? That's a symmetrical rock formation, and it was created by erosion. However, if we looked at these things from space, they'd look artificial. So, what is the square? How about a fracture pattern in the rock or some terrain that's broken apart along straight lines due to stress? This happens on Earth all the time when rock expands and contracts over time. And on Mars, the surface is just constantly battered by meteors, winds, and extreme temperature shifts. No wonder rock would get stressed. What happens here is another case of pareidolia. It's our brain's favorite thing, to spot patterns in something random. Hey, we evolved like this. So sometimes we might look at natural objects and see insane stuff. Faces on trees, animals in clouds, shapes, and so on. Besides, NASA has been photographing Mars for decades. We have high-resolution images of craters, mountains, valleys, riverbeds, hey, everything. Wouldn't an ancient civilization leave us, well, something better than some square-like rock? Even though things erode over time, we'd find more signs, roads, foundations, artifacts, ruins, or at least something. Though, to be fair, we do see something. The square wouldn't be the first time Mars has played tricks on us. Over the years, we've spotted everything, from tunnels to carved faces, even Bigfoot. Or this doorway, for example, a perfectly cut rectangular opening. That's what people saw when NASA's Curiosity rover sent back an image of the East Cliffs on Mount Sharp. It's almost like an ancient passage leading deep into the surface. You just need to go in and find some fantastic underground base. Well, NASA decided to take a closer look at it. It turns out it's just 12 inches tall and 16 inches wide, the size of a dog door. That's because what we're looking at isn't a doorway, but an open fracture, a break in the rock that happens naturally over time. These kinds of cracks are extremely common, both on Earth and on Mars. They form when bedrock is stressed, expands, contracts, or gets eroded by wind and time. If you walk through a desert here on Earth, you'd see plenty of similar shapes. Canyons, cliffs, and even boulders have fractures that, from the right angle, might look like doorways. They're just not getting photographed by NASA. Also, the straightness of lines turns out to be just a trick of perspective. If you zoom out, you'll see that it's just one small break in a much bigger rock formation. Or the infamous Cydonia face. The photo was taken back in 1976 by NASA's Viking 1 orbiter when it was scanning Mars. In the region known as Cydonia, it captured what looked like a massive humanoid face, a rocky formation about 1.2 miles long. And this one face inspired books, documentaries, movies, and podcasts. But when NASA's Viking orbiters first took pictures of Cydonia, the cameras weren't super advanced. The image of the face had a low resolution and made the details fuzzy. NASA's later missions had far better cameras, and when Mars Global Surveyor revisited Cydonia in 2001, the truth was undeniable. The face was just a hill, a lumpy rock formation with ridges and depressions carved by wind and erosion. And in 2006, during another mission, a colored image with insanely high detail was made. No traces of face left there whatsoever. That's another pareidolia trick for you. Now, Mars has plenty of secrets left to uncover, but they will be related to its fascinating history, not some secret ancient civilization. The conclusion is, don't trust everything you see online. Sometimes a mysterious rock is just a rock. Uh-oh. Something is nearing the surface of the planet. It looks like a fireball hurtling closer and closer at a truly incredible speed. Soon, it becomes obvious that the collision is inevitable. Bam! The impact leaves a huge crater. It evaporates thousands of cubic miles of solid rock, and it also sets off a series of terrible natural disasters. Yeah, I know what you're thinking. You believe I'm talking about the catastrophic collision that occurred around 66 million years ago on Earth. You know, the one that's responsible for the extinction of non-avian dinosaurs and 3/4 of other life forms on our planet? But no, the disaster I'm talking about happened on a different planet. Scientists think that our close neighbor, Mars, once experienced the same catastrophe that struck Earth. It happened around 3.4 billion years ago. An asteroid collision might have caused a mega tsunami on the red planet, similar to the one that caused the Chicxulub impact on Earth. Scientists have identified an impact crater on Mars that was probably left by a comet or asteroid collision with the surface of the planet. Most likely, the space body landed in an ocean in the Martian northern lowlands, and the impact was so powerful that it caused a mega tsunami. Before the latest studies, the exact location of the impact crater wasn't verified. It was just a theory. To confirm it, a team of astronomers simulated a comet and asteroid collision in the area where they supposed the impact crater was. They even named this crater Hall. Hall is 68 miles across and lies in a region that is almost 400 feet below the supposed sea level. Anyway, the simulations formed several craters of the same size as Paul. One of the simulations claimed that these craters had been left by a 5-mile-wide asteroid that had encountered strong ground resistance. The other simulation showed that the craters had been caused by a bit smaller asteroid that met a weaker ground resistance. But, according to both simulations, the impact crater was almost 70 miles in diameter, and the collisions produced mega tsunamis up to 900 miles away from the center of the impact site. The simulations also helped scientists estimate the height of the tsunami. It was about 820 feet tall, almost as tall as the Eiffel Tower. The authors of the study also suggest that the Pole crater might be similar to the Chicxulub impact crater on our planet. The Chicxulub asteroid, as we now know it, is believed to come from the outer reaches of the solar system. This space body was at least 6 miles across. It crashed into the shallow seawaters near the Yucatan Peninsula. This splashdown was so powerful that it left its signature on the entire face of the planet. In 2021, researchers found out that the collision had carved mega ripples into Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists remodeled the events of the first 10 minutes after the impact, and the model showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. That's like 2 Burj Khalifas, which is the tallest construction in the world, stacked one on top of the other. And of course, all that empty space didn't stay empty for long. The ocean gushed back to fill the crater. But in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. Imagine a 3-story building rushing up to you. No wonder the largest and fastest-moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall, which is taller than the Statue of Liberty, and moved at a speed 10 times greater than more distant tsunami waves. But back to the Red Planet. Some experts think that not 1 but 2 mega tsunamis could happen on Mars. They could be triggered by a pair of meteor impacts that were several millions of years apart. Between these 2 collisions, Mars went through a period of climate changes. As a result, liquid water on its surface turned into ice. In other words, the first asteroid impact most likely produced waves composed of liquid water, and the second tsunami was probably formed by rounded chunks of ice water. By the way, the largest asteroid to have ever crashed into Earth might not actually be the one that ended dinosaurs. A much more catastrophic collision likely happened about 3.5 billion years ago. New evidence scientists found in northwestern Australia suggests that the asteroid I'm talking about was 12 to 18 miles across. It struck Earth at an immense speed, releasing an unimaginable amount of energy. Now, this made me think, what if something like that happened these days? More than 30,000 objects that are circling Earth these days could potentially crash into our planet. NASA considers around 1,500 of them to be potentially hazardous. These space rocks are the remains left after the solar system was formed some 4.6 billion years ago. For example, in 2004, astronomers discovered a huge asteroid nearing Earth. The first observation showed that the chance of the space rock hitting our planet was less than 3%. The asteroid was named Apophis. It's more than 1,200 feet across and weighs about 20 million tons. It's supposed to streak across the sky on April 13, 2029. Apophis will pass at a distance of 19,000 miles away from Earth's surface. But even though this space rock might miss our planet in 2029, it doesn't mean it won't return 15 years later in 2036. If such an object hits our planet, the consequences will be unpredictable. They can vary from shattered glass and broken windows to most life forms getting wiped off the face of the Earth. And it'll probably affect the internet. Now that last thought is truly scary. But luckily, modern technologies are likely to help us avoid any catastrophic consequences. Experts have developed several ways to prevent a real-life disaster movie from happening. For one thing, we could use a spacecraft to knock this visitor from outer space off its course. Or it could somehow be blasted into pieces. Scientists could also slow the thing down with the help of concentrated sunlight. Or people could tug it away with a gravity tractor. That's a theoretical spacecraft that can influence objects in space without touching them. In sci-fi movies, a huge asteroid often sneaks up on Earth and turns out to be a nasty surprise to astronomers. It hurtles toward our planet at breakneck speed and gets discovered just weeks or even days before the collision. In reality, scientists are constantly watching all large objects in Earth's neighborhood. It means there would be plenty of time to do something before the inevitable happened. There are 3 kinds of missions scientists could prepare at short notice. Type 0, when a heavy spacecraft hurtles toward the intruder with one single goal: to knock it off its course. In this case, astronomers would have to rely on the already available information. The Type 1 mission would involve a scout. It would be launched first to get more close-up information about the space rock. Only after that, the main spacecraft would be launched. With more precise information, its journey would be way more productive. And if scientists chose the Type 2 mission, they would send a scout and a small spacecraft at the same time. The spacecraft would knock the asteroid a bit off its course. Then the scout would collect all the necessary information. Based on this data, the spacecraft would finish its job with a more fine-tuned second push. If none of these methods work, people could try going deep underground or even build a shelter on the ocean floor. But in this case, we'd need to find sources of energy that could help us survive for at least several decades. Plus, people would have to create a life support system that could somehow keep air and water fresh.
Something is happening on the red planet! Scientists believed that they knew nearly everything about its atmosphere, but a NASA rover has discovered something unexpected. There's more oxygen on Mars than they thought, and it behaves in weird ways. In the spring and summer, oxygen levels go up even more, and no one knows why. Now, you might think that when there's oxygen in an atmosphere, it's mostly because there's life somewhere around, like trees on Earth that produce oxygen through photosynthesis. But on Mars, it's not that simple. Non-living processes can also create oxygen, so we can't surely say that its presence means there's life on Mars. Mars has long been one of the main candidates when it comes to looking for signs of extraterrestrial life. Back in the 90s, scientists announced they had spotted potential proof there could be life on Mars because of microbes they had found in a meteorite that had arrived from the red planet. It looked like they had found fossils of bacteria. They actually stumbled upon tiny crystals of magnetite in the meteorite, which they believed could only have been produced by living organisms. It was such a mind-boggling discovery. People were excited, but many were also skeptical. It didn't prove there really was life on the red planet. Maybe there was life there a long time ago. The meteorite is thought to have originally formed on Mars billions of years ago, and to have landed on Earth thousands of years ago. Skeptics soon started to pick apart the evidence and eventually found some things that didn't make sense. For example, these magnetite crystals. No one could be sure how they formed. Why do they have to be bacteria? Some research has shown they could be the result of shock waves. Recently, the Perseverance rover has collected a couple of new rock samples from the Jezero crater on Mars. The theory says that about 3 billion years ago, before the red planet lost most of its atmosphere and basically just dried out, there was a big lake with a river flowing from it in that area. Whoa, what a great environment for life! Perseverance studied mud samples it had found on the bottom of the evaporated saltwater lake. Scientists were amazed to see a record number of sulfate molecules, something we usually find in mollusk shells on our home planet. Such organisms evolved a couple of 100 million years ago, but maybe there was a time when some of their space ancestors lived in water bodies on Mars. Mars has weaker gravity than Earth, which means these weird species could have got really big there, way bigger than their Earth cousins. Gravity plays a significant role when it comes to limiting the size of organisms. Bigger organisms need more energy to move against gravitational forces, but the creatures that may have lived there long ago are just a mix of hypothesis and our imagination, something that's still really hard to prove. Meet the Curiosity rover, another robot NASA is using to explore Mars. Curiosity has been in charge of measuring the composition of the atmosphere of the red planet for many years now. The rover has discovered that it mostly consists of carbon dioxide and a little bit of nitrogen and argon. The atmosphere of Mars has only 1/10 of 1% of oxygen, since, as far as we know at the moment, Mars doesn't have plants that could produce enough oxygen. But Curiosity has also discovered anomalies no one can really explain. It's found out that there are spikes in oxygen levels in the Gale crater during the Martian spring and summer. Every year, oxygen levels go up and down in unpredictable patterns there. What's even more interesting is that the oxygen spike is similar to a seasonal spike in methane, which is a gas we often associate with life on Earth. No wonder scientists are scratching their heads and wondering if there's a connection between the two gases, and if they both come from the same source on the Martian surface. Is there something big that breathes there? Come on, we'll be happy even with some small space worms in the soil. There's a type of salt called perchlorates in the Martian soil. Some scientists believe perchlorates might be responsible for the strange spikes in oxygen levels. But like with most things we know about space, it's just a theory. Also, scientists think that perchlorates breaking down in the Martian soil release oxygen too slowly to cause and explain the sudden increase in oxygen levels. One of the suspects is hydrogen peroxide, which is like water's unstable cousin. Hydrogen peroxide forms when sunlight breaks up carbon dioxide and water vapor in the Martian atmosphere. It can seep into the soil and stick to particles underground, which means it forms some kind of oxygen storage tank. Some data even show there are pockets of subsurface water in the Martian soil that may be hiding enough dissolved oxygen to actually support life. But even if the hydrogen peroxide could stay in the soil for millions of years, it would still only explain a small part of the increase in the level of oxygen. So you can't blame it for the whole thing. We can also take a look at an old experiment from the 1970s, where scientists found that moistening the Martian soil caused it to release a lot of oxygen. However, they did this experiment at a warmer temperature than the planet's average. And again, it doesn't explain how the oxygen spike keeps happening every year. None of the clues we have seems to fit the case. Mars may not have enough of its own oxygen, but it's possible to make this gas there. NASA conducted a small experiment where they tried and managed to produce oxygen on Mars. MOXIE is a device that can make oxygen on Mars. It managed to produce enough oxygen for an astronaut to breathe for 100 minutes. This awesome device worked in pretty tough conditions, at night or during the day, at extreme temperatures, and during the crazy dust storms the red planet is known for. Despite all this, MOXIE still kept up with producing high-purity oxygen. MOXIE is a clever device that can make oxygen on Mars by taking in carbon dioxide from the planet's atmosphere and heating it up to incredibly high temperatures. This allows the device to pull oxygen atoms from the carbon dioxide and produce breathable oxygen gas. If we want to use MOXIE to make enough oxygen for human missions to Mars, we need to make a bigger version of the device. But if we make it bigger, we might have trouble keeping it at the right temperature and making sure it heats up evenly without breaking. The ultimate goal would be to create an oxygen device that could continuously support a human mission for about 400 days. With a bigger version of MOXIE, we'd have enough oxygen to support crew members and even propel a return rocket to our home planet. When you see the dusty red surface of Mars, you can't say it's a place that hides liquid water underneath. Some say it's too cold for water to exist on Mars anyway. But there are stories that there could be a hidden world of liquid water, just like subglacial lakes in Antarctica. And to find out more, we might have to drill down about a mile beneath the surface. Unfortunately, it's not going to happen anytime soon. But in the meantime, scientists have been using a spacecraft called Mars Express to study radar reflections around the southern pole of Mars. The reflections seem to indicate there could be liquid water, and the planet's interior might be keeping it warm. But some claim it might just be rock. We hope there are underground lakes on Mars because it would be a perfect spot to look for life. After all, scientists have found bacteria living in subglacial lakes on Earth, but we don't know for sure how deep they are or if they're just small veins of water in the ice. Only time and more exploration will tell.
So imagine being one of the first people sent to explore Mars. As you're approaching the red planet, something strange and creepy draws your attention. There, yes, right there. Doesn't it look like a mammoth bear's head? What or who could possibly create a bear's snout in the middle of a crater? Unfortunately, or should I say luckily, there's nothing mysterious about the bear's head. It's just a facial pareidolia. That's a tendency to see facial features in everyday things. But speaking about the finding on Mars, should we rename the phenomenon into Pareidolia? You could see that coming, couldn't you? Alright, check it out. You see a V-shaped hill that looks like a nose. Then there are two craters that look like eyes. And then there's a circular fracture pattern, the head, that surrounds the nose and the eyes. Experts think that the face could be created when a deposit was settling over a buried impact crater, and the nose might be a mud or volcanic vent with solidified lava or mud flows around it. Anyway, the crater does look like a bear's face, I'll give you that. But thanks to HiRISE, the Mars Reconnaissance Orbiter's high-resolution imaging science experiment camera, another of NASA's amazing acronyms, we've seen many other crazy craters on the red planet, like smiley faces, a bird, or an elephant. First, let's have a look at the famous face of Mars. These images were first taken by the Viking orbiter in 1976. At that time, the resolution was obviously quite poor, plus the lighting was slanted, which produced the result that shocked people in the 1970s, a face carved of rock staring back at Earth. Did it mean there was another civilization on Mars that had created this monument? Nah. Look at the photo of the same spot taken by the current Mars Reconnaissance Orbiter. The resolution is much, much better, and the face has miraculously turned into an ordinary hill. Or look at this teeny Bigfoot, whose image was captured in 2008. I say teeny because this creature is just a few inches tall, and when the photo was taken, Bigfoot was only several yards away from the camera. And here, one curious soul zoomed in on a small rock and spotted something that resembled a gorilla. That's how some people started to believe there were apes on Mars. Yeah, really. Let me show you some more examples of imaginary creatures and faces on the red planet. Most of them come from a series of images taken by the Themis camera. Currently, it's on board the Mars Odyssey spacecraft, which only needs 2 hours to orbit the red planet, carrying some important scientific instruments. Let me introduce my happy Martian to you. This 2-mile-wide crater was photographed in 2008. The next crater chain looks like a wasp with its wispy wings of impact debris. The whole feature was probably created by a meteorite that fell at a very low angle and broke into pieces right before the impact. Now, do you see a woolly mammoth or an elephant here? Lava flows in one region on Mars left this image on its reddish soil. The region itself, called Elysium Planitia, is famous for the planet's youngest lava flows. For example, the one that looks like a mammoth most likely formed in the past 100 million years. Just yesterday. Now let's talk about love, or rather its symbol, the heart. Do you like these two hearts on the surface of the red planet? This one is actually a mesa top outlined by frost, and this heart shape is an impact crater. The hit tore away dark surface material and exposed lighter soil underneath. Then some of the material probably flew downslope, creating the heart. And this dust-covered hummingbird, can you see its long beak and head? Scientists aren't sure how this shape was formed, but they think erosion and wind played a part in its creation. These dark sand dune deposits look like a howling wolf. And here, can you see a series of interlocking gears? This image looks like the letter T, right? The right angle fracture was created by the tectonic stretching of the Martian crust. Do you think we might find other letters of the alphabet on Mars too? Why not? And now, how about another bizarre thing astronomers noticed on the surface of Mars? Is that a door to someone's house? It was NASA's Curiosity rover that sent this image to Earth. It became viral because this formation over here, see, looks like a door. Unfortunately, scientists, due to their rational minds, were quick to disappoint us. They claimed that it was just a natural part of the Martian landscape. There were several clues that made them think it wasn't a real door. For example, the opening is tiny, a mere 3 feet high. They're sure that what looks like a door is actually an opening in a rock created by natural forces, like winds and erosion. If you look at the rock closely, you may notice strata. Those are layers of silt that stand out because they're harder than the surrounding material. These strata dip here on the left and a bit higher on the right. They likely appeared around 4 billion years ago in a river or a wind-blown dune. Since the strata became visible, powerful Martian winds have eroded them even more. And look at this. See those cracks? That's how rocks weather on the red planet. This small cave probably formed when several fractures crossed the strata. A pretty large boulder might have fallen out under its own weight, and this created the door-shaped opening. This theory is quite plausible, because even though the gravity on Mars isn't as strong as on Earth, it's still strong enough to do it. Besides, see that rock to the right of the opening? It has a suspiciously smooth vertical edge. It must be the culprit. It probably fell out not so long ago. But it's not only the red planet that can boast of having unusual formations. Let's take this comet, for example. This image was taken by the European spacecraft Rosetta in 2014. Can you see a face on its right-hand side? Or the moon. Here's its famous rabbit. It sits upside down with its ears pointing downward. Some people see a man on the moon. It can either be his face or the entire body. If someone sees the whole human figure, it usually looks like it's carrying sticks. Sometimes it's a toad. To spot it, look at the top left-hand side of our moon. The toad is facing upward, see? Now look at this spinning neutron star. Such a star is a collapsed core of a supergiant star with a total mass of 10 to 25 solar masses. Except for black holes and some hypothetical objects, like quark stars or white holes, neutron stars are the densest and smallest known stellar objects. Anyway, back to this particular star. As you can see, this space object, located 17,000 light-years away from Earth, is surrounded by a cloud of energetic particles. And this image, taken by NASA's Chandra X-ray Observatory, appeared in 2009 and became viral in no time. All because many people spotted a hand-like structure among all that space stuff. NASA explained that the star was spinning incredibly fast, spewing energy into the space surrounding it. This created intriguing and complex structures, like the large cosmic hand so many people see. Now look at the Horsehead Nebula in the constellation Orion. This is a freezing cold and dark cloud of dust and gas that was first noted in 1888. This dark shadowing is created by dust, and at the base of the nebula, there are many bright spots. Those are young stars at the stage of formation. Pay attention to this extremely bright star in the top left side of the Horsehead. Its radiation is so powerful that the star is starting to erode the cloud around itself. It means that, in millions of years, the nebula might not resemble the head of a horse anymore. Well, I won't be around then. The European Southern Observatory Very Large Telescope has captured an image in which we can see the collision of 3 different galaxies. We can even observe the effect they have on each other. But the coolest thing is that, while colliding, they created a recognizable shape. Because doesn't it look like a giant space hummingbird? NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the red planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements and gathering data about the planet for more than 10 years. And good old Curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kind of expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of a dried-up lake and all that sediment and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now, a spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is cacao, and it's about the size of a small car, 6.5 feet long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, so that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while cacao is metallic-looking and dark gray. It's rounded and smooth, too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars, too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with light-colored material surrounding them. And the cool thing is that these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way the winds blow. But back to our buddy, Curiosity. It's been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why, though, and of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. Now, this doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of life a long time ago. Curiosity discovered potential evidence that there might be a large reservoir of liquid water beneath the south polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars, because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, there are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. Now, it's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So, you never know. There might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time. And one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars's atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space. So Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the red planet back in its old times. There's this story about an ancient megaflood that might have happened there. So yes, the red planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this megaflood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water, too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that? Well, here you are. You're the first person to set foot on Mars. And your first mission is to explore a place called Jezero Crater. You're wading through the thick, rust-colored dust when suddenly you trip over something and almost fall. You lean closer to examine the culprit and recoil in horror. A skull is staring back at you. Who did it belong to? An ancient Martian dinosaur? A representative of a long-lost civilization? Now, this isn't a made-up story. That's what NASA's Mars robot called Perseverance would tell you if it could speak and, had consciousness. The rover had indeed found something strange, but it wasn't a real skull. It just looked like one. In reality, those were rocks that seemed to be out of place on the red planet. Right now, Perseverance is exploring the edge of a big, empty bowl-shaped area called Jezero Crater. Scientists think that a long time ago, this crater held a giant lake. Perhaps it was even full of tiny life. Since December 2024, the rover has been rolling down a steep hill called Witch Hazel Hill. It's an important mission because this hill might hold secrets about what Mars's weather and environment were like billions of years ago. Anyway, on April 11, 2025, Perseverance stopped to look at a special spot where two types of rock meet. One was light-colored and the other was dark. And right at that spot, scientists saw a weird-looking rock they later named Skull Hill. It stood out dramatically because it was dark and had a sharp shape. But the creepiest thing? It was full of little holes, a real nightmare for those with trypophobia. So NASA shared this discovery in a blog post. They explained that Skull Hill didn't look like the other rocks nearby. The area where Perseverance found these strange rocks is called Port Anson. Scientists think that many of the rocks there didn't originally form in that spot. They were moved from somewhere else an exceptionally long time ago. But how did they move, or what moved them? Now, don't get your hopes up. It doesn't mean we'll find space neighbors on Mars. These kinds of rocks are called floats. They are likely to have traveled a long way across Mars billions of years ago, back when the planet was much warmer and wetter, with rivers, lakes, and maybe even oceans. As the water dried up and the soft ground around the rocks slowly wore away over time, the tougher rocks stayed behind, sitting on the surface. Now scientists are trying to figure out how the strange holes on Skull Hill were made. One idea is that tiny parts of the rock broke off and wore away over time, leaving behind little pits. Another idea is that Martian winds, which carry dust and tiny rocks, might have slowly scraped the surface, kind of like sandpaper, and created the holes. Skull Hill is dark-colored, and at first, scientists thought it might be a meteorite that had come from space. But when they looked more closely at the chemicals in the rock using Perseverance's supercam, the results didn't match what you would expect from a typical meteorite.
Nope.
So, scientists now think Skull Hill might be a volcanic rock. On both Earth and Mars, dark volcanic rocks get their color from minerals like olivine, pyrozine, and biotite. If Skull Hill is volcanic, it might have come from old lava flows nearby that have broken down over time. Or maybe it was blasted out of the rock during a huge crash, something like an asteroid impact, that dug deep into the ground and pulled up volcanic rock from below. What helps scientists in their research is that Perseverance now has some cool tricks that help it figure out what Martian rocks are made of. That's how we can learn where the rocks came from and how they formed. Lately, the rover has been super busy. In just a few months, it has collected samples from 5 rocks, studied 7 rocks very closely, and blasted 83 rocks with its laser to learn about them from a distance. That's the fastest pace of research since the rover landed on Mars 4 years ago. At least that's what NASA's Jet Propulsion Lab says. Usually, it can take months to find just one interesting rock in a crater. But up on the edge of the crater, aka the rim, cool and strange rocks are popping up all the time. Scientists are especially excited about getting these rock samples back to Earth to see if they'll show signs that life ever existed on Mars. But there's a problem. The plan to bring the samples back, called the Mars Sample Return Mission, is really complicated, expensive, and running into delays. So, for now, the samples are staying on Mars, waiting for their ride home. Hey, Uber! There's another rover that is currently working hard to help us get more information about our neighbor. That's Curiosity, and it might have found a clue about what happened to Mars's atmosphere from billions of years ago, thick and carbon dioxide rich. If the red planet once had warm temperatures and flowing water, what are the signs of all the carbon that should have been left behind? Now normally, a planet like that would have carbonates, minerals made when carbon dioxide reacts with water and rock buried in its soil. But on Mars, very few carbonates have ever been found, which has been a big mystery. Now, scientists might finally have an answer. A new study suggests that iron carbonate, called chytriid, may be hidden inside Mars's sulfate-rich rock layers. These layers weren't easy to spot in satellite images from orbit. That might be the reason why carbonates may have gone unnoticed for so long. At one point in the past, Mars's carbon cycle got out of balance. The rocks started pulling in more carbon dioxide than they were releasing. Over time, this may have caused Mars to lose too much CO2 from its atmosphere. It cooled the planet and made it dry and lifeless. The planet might have been still habitable when this happened, but once carbon dioxide started turning into chytriid, Mars may have begun getting too cold to support life. The Curiosity rover found these carbon-rich rocks in Gale Crater, an area on Mars that used to be full of water. The rocks also contain a lot of salts, which usually form when water dries up. This supports the idea that Mars went through some huge changes, likely from a planet with a nice climate to the cold, dry world we see today. If scientists find more chytriid in other parts of Mars, it could help explain where all that ancient carbon dioxide went. Even better, it would support the idea that Mars was once warm, wet, and maybe even habitable. But that's not the only discovery Curiosity has made. The rover has a set of special instruments called SAM. Now, SAM's job is to study the rocks, dirt, and air on Mars to learn more about the planet. And one of SAM's biggest findings happened when it studied rocks from Gale Crater. SAM found organic molecules. Organic molecules are special because they're made of carbon, and on Earth, carbon is super important for life. Plants, animals, and people are all made from carbon-based molecules. So, finding these molecules on Mars makes scientists wonder if it's another proof that Mars once had life, a long, long time ago. When SAM looked even closer, it found certain patterns in gases like carbon dioxide and methane. These patterns might match what you would expect if tiny ancient life forms were making organic molecules. But there's also another explanation. These molecules might have been made by sunlight reacting with gases in Mars's air. In this case, no life would have been involved at all. On Mars, strong ultraviolet light from the sun can break apart and mix up molecules, creating new ones that eventually land on the ground. So even though scientists don't have a clear answer yet, finding organic molecules is a really big deal. At the very least, it tells us that Mars had the right ingredients for life, even if we don't know yet if life actually existed there. Now, scientists are using SAM and Curiosity's other tools to keep searching for more clues. It's staring at you, and you're staring at it. A giant eye that seems to be pulling you into an abyss. You're hovering over it in your space copter. But however scared you might be, you still need to do your job. So you send your copter down to the surface of the red planet. Right, that's where you are, on Mars. But first things first, you take a moment to remember everything you know about the fourth planet from the Sun. It's the last of the inner planets. Those are the planets that lie within the asteroid belt. They're also called terrestrial, since they're made up of rocks and metals. The atmosphere of Mars is much thinner than Earth's. It contains 95% carbon dioxide and a mere 1% of oxygen. In other words, don't even think about pulling off your helmet. Anyway, there's no time to waste. You land on the surface of the planet and find yourself in a brownish-red world. That's a good thing you're wearing a spacesuit. This place is freezing cold. The thermometer sewn into the sleeve of your suit shows minus 80 degrees Fahrenheit. Time to take your first step on the Martian surface. The planet looks quite colorful, and the hue of a particular area depends on the minerals that make up the soil. The ground under your feet is covered in fine dust. It looks like rust. The same orange dust is in the air. Good thing you have your own supply of oxygen and don't need to breathe Martian air. The layer of this dust covering the surface of Mars can be from 6 to 40 feet thick. You hope you'll avoid getting swallowed by some Martian quicksand. You start walking, feeling very light. Mars is just 15% of our planet's volume and a mere 11% of Earth's mass. It means that gravity here is much weaker. Its pull is 38% as strong as the pull of gravity on the surface of Earth. You jump up and down and then try to run several hundred feet. Ha! You haven't even broken a sweat. What makes it harder for you to explore the place on foot is that the planet's surface is rocky, covered with craters and volcanoes, old dry lake beds, and canyons. You see something huge towering on the horizon, but you try to suppress your curiosity. You'll have enough time to figure out what it is later. Suddenly, a massive cloud appears in the distance. It looks as if a huge herd of horses is approaching you. In reality, you better get back into your copter and fly away as fast as you can. That's one of Mars's infamous dust storms. They mostly occur during the summer in the southern hemisphere of the red planet. They can sometimes cover the entire planet, and you see the largest ones from Earth. You hop into your copter and set a course for the eye that scared you so much. Winding channels that look like veins run through the eyeball. But the closer you get, the less it looks like an actual eye. Soon you realize it's a crater. It's giant, almost 19 miles across. Around the crater, which looks as if it has a pupil, there are other even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once there was Martian water in the enormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Now, remember that towering something on the horizon? It's time to go and explore it. When you come close, you realize it's the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which is almost the same size as the state of Arizona. You tilt your head. Wow! The mountain is 16 miles high. It's also rimmed by 4-mile-high cliffs. To picture the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, towering around 2.5 miles above sea level and stretching 75 miles across. Sounds impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. But why is this volcano so large? It might be the result of lower surface gravity and higher eruption rates. Or the reason might be the red planet's crust, which is very different from Earth's. It's static. You see, on our planet, the crust is made of 15 to 20 moving tectonic plates. As plates move over hotspots producing lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. So, how about getting closer to the enormous mountain? But once you step out of your copter on Martian soil, the ground under your feet starts shaking. Well, that's a Marsquake. But how can it happen if Mars doesn't have any actively shifting tectonic plates? Specialists from NASA are sure Marsquakes occur when energy inside the planet gets suddenly released. It leads to rock fractures and cracks in the planet's crust. Another powerful jolt, and one of such cracks opens right next to you. You fall to the ground, afraid to move, but soon everything calms down. You wait for a couple of minutes, just to be sure, and get up. Oh look! Here's a perfect opportunity to explore the insides of the red planet. The crack is large enough to send a special research robot. The planet's crust is thin and consists of volcanic basalt rock. The mantle that surrounds the core of the planet is made up of thick silicates, oxygen, and some minerals. You can probably compare it with soft, rocky toothpaste. Mars's mantle is also much thinner than Earth's. It's just 800 to 1100 miles thick. As for the planet's core, it's made mostly of iron, nickel, and sulfur and is between 900 and 1200 miles wide. This core doesn't move. That's why Mars doesn't have a planet-wide magnetic field. Unfortunately, your drone is now lost in the depths of the red planet. You leave it there and continue your exploration. Your next destination is Valles Marineris. It sounds more like an Italian red sauce, but it's actually an enormous canyon, or rather a canyon system, that runs along Mars's equator. It's as awe-inspiring as Olympus Mons, more than 2,600 miles long and over 4 miles deep. The thing is so huge, it could span the entire continental United States from the Pacific to the Atlantic Ocean. Now let's make another comparison. One of the most famous canyons on Earth is the Grand Canyon in Arizona. But it's 10 times shorter and around 4 times less deep than this canyon on Mars. Some scientists think that Valles Marineris is the edge of an enormous tectonic plate. It moves so slowly that almost nothing has happened in that region over millions of years. And the movement of this plate probably began 3.5 billion years ago. Anyway, the only thing left on your today's to-do list is to visit Mars's moons. They're among the tiniest in the solar system. Phobos is the largest of the two. It orbits a mere 3,700 miles above the surface of Mars. There's no other known moon that travels closer to its mother planet. It whips around the red planet 3 times a day, while the second moon, Deimos, needs 30 hours to complete one orbit. Phobos is getting closer and closer to Mars, about 6 feet each 100 years. Within the next 50 million years, it'll either crash into the planet or break apart and form a ring. Happy but tired, you return to your spaceship. Tomorrow, you'll continue exploring the magnificent red planet, and who knows what discoveries are awaiting you.